Next, we have the lens, which is located behind the pupil. Its job is to focus on the incoming light onto the retina. This is the thin surface located on the back of the eyeball. And with that, the accommodation is a process that happens there, and this is the process of the lens changing and bending to focus on near or far things, such as like the car 10 feet in front of you or the tree 20 feet away. So, the fovea, located in the center of the retina, is the point of focus where acuity is at its highest. Next we have, so this is like a zoom up, this section of this right here. So imagine these go into that, okay? So next we have the optic nerve, which is this twisty thing right here. And that's responsible for sending the information of like the car you just saw to your brain for processing. Within this little cross section right here, we have the rods and the cones, which are these right here. So the rods are for seeing black, white, and gray. They are not in the fovea, while the cones detect detail and fine color, and they are clustered in the fovea. So one of these pink and one of these blue would be the rods, and the other would be the cones. So the bipolar cells, which are right next to them, are this black row right here. They transmit information from the rods and the cones to the ganglion cells, which they make the optic nerve, which takes info to the brain. So the thalamus right here, the thalamus processes all the senses and relays them to the brain. This happens to sight as well as other senses. So yeah, I don't know if I pointed them out, but the ganglion cells, they bring it to the optic nerve. So next we have the feature detectors, which are near the thalamus right here. And the feature detectors are cortical neurons that respond to certain features of stimuli. They detect things like movement, shape, and angle. They're right here. And the optic chiasm, which is, here's a different diagram. If you're, imagine looking at the brain from the bottom, this is like a brain from the side, this is one from the bottom. So the optic chiasm is where the optic nerve fibers from each eye cross over each other, and they do this because each side of the brain processes the opposite eye, and they bring it to the occipital lobe. So yeah. So next we have the blind spot, which is this right here, and the blind spot is the place where the optic nerves leave the eye. So there's no receptor there, so it's literally a spot where you're blind, but your brain fills this field of vision. The occipital lobe is the part of the brain that deals with processing the vision, and within the occipital lobe, there's the visual cortex, which is the part of the cerebral cortex that's involved with vision. So here are those two areas, green, occipital, and the red is the visual cortex. Next, we have two theories which are not on our paper, but I will explain them. So there's the trichromatic theory, which is basically the theory that the retina has red, blue, and green receptors, and when these colors combine, they can produce any color of our vision. And then there's the opponent process theory that states that opposing processes in the retina, such as red and green, black and white, are what enable our vision of color. So, thanks for watching. Yeah.